we are done with our spiral planar geometry of circular coil. Now, what is the issue with this is the spiral structure takes a lot of time to simulate. So if you want to do your parametric study here, what we did our parametric study from, like with respect to distance between the receiver and transmitter coil, which we were calling as air gap, right? It is known as air gap only. So if we are doing our parametric study for more number of values, it will take a lot of time to simulate. Even just for one value also, it takes a lot of time to simulate. So what we do is we don't just we don't simulate this spiral structure, but instead we just draw a solid plate here. Instead of this spiral structure, we will just draw a circular solid plate there, and will give their excitation. So it will be like it will have some inner radius, right? Just wait, I will so it will look like this. So you need two solid plates. First, for the outside diameter, and second for the inside diameter, right? For circular coil, you have two diameters, right? And again, even for circular, the spiral structure is available. But what if, see, mm, for wireless charging of electric vehicle, these types of coil are widely used. So this is like the commonly used coupler coil. So first is circular that we simulated, right? Can you please mute your mic?
Hello, ma'am. Yeah, ma'am.
Hello, hello.
Yes, ma'am.
Okay, I was not audible to you guys.
Now you are audible, ma'am.
Okay, okay. Sorry. So I was speaking, but I think my mic was on mute. So I don't know till what you have listened. So I was saying that these are the commonly used coil structure for EV charging, right? So for making the spiral structure, default option is available, right? But what if you want to make a rectangular coil? For square coil also default is available. We can just change the number of segments to 4. That day I showed you that, right? Do you guys remember?
Yes, ma'am.
But if you want to make a rectangular structure, it is difficult to do so, right? With spiral, like this spiral in spiral form. And above that, we have like DD coil. So we have two rectangular coil placed like this. Then we have DDQ coil. So there are three rectangular coils like this. So first, if you will work with this spiral structure, first it will take a lot and lot of time to get simulated. And secondly, it will take a lot of effort also, right? So that's why instead of using this spiral structure, what we will do is what we have done in transformer thing. There what we did, we use a solid block as our coil, right? Right? Instead of the wound structure, we use a solid block. So here
Yes,
also,
ma'am.
we will not use the spiral structure. Mostly we will make our coils in solid structure only. So after you will you learn this, you will, I don't think you will ever use this spiral structure. Fine. So today we will learn how to simulate it in solid form, right? Not in this spiral form. Understood? You understood the importance?
Yes, ma'am.
Okay, so let's just take a new simulation here. So few things I want to tell first. See, um if I want to make a square with uh, if I want to make a square structure with um means in spiral form, it is easy, right? You have to just change this number of segments to 4, right? So you can get a square structure like this. Okay? This is just for example. So you can get this square structure like this, but you cannot get rectangle from this. You can only get square, right? So what if you want to draw a rectangular coil? So this option you cannot choose, right? So only square and a circular you can make with this, right? Understood? Then for making rectangle, one more option is available. What you can do is these are just the option that I'm telling you, but at last I'll just tell you how to how to make a coil just using a solid blocks. Okay, and I think that is more than enough like for you to simulate any coil. So uh, just like different even though I'm telling you this different option, I don't think you will ever use this. Okay, I don't use it. I work in wireless power transfer. I also don't use this option. Okay, but just to tell you that what are the options available, I'm just letting you know. Okay. uh then so second is you can just you can draw a line. What's happening? Huh. For drawing a rectangular coil, you can draw a spiral structure like this. And then what you can do is you can just change its type to circular and then give some width to it, right? So in this way also you can draw your rectangular coil. See, this all like positions and all you have to measure and do this, huh? For now I am doing randomly, but you have to do it by measuring and all. Okay, so this is how we have extended our leads from the coil, right? This way we used, right? So through this also you can make your rectangular coil in the spiral shape. But this also is like it will be very time consuming because you have to take care of each and every point. Then you have to take care that this will not touch. So that like diameter and all also you have to take care of. But above this, if you simulate your rectangular coil in this spiral way, it will take a lot of time to simulate, even a day or so or more than that. Okay. So this all option also we don't use normally. So what we do is we make our coil in solid form. So that we will start now. We will draw a circular coil only. Okay. For circular coil, what is the option? Draw cylinder. Radius, it was 30 around, right? Height is your wire diameter, right? So the radius of this is 30 and the height is this is 2 mm, right? So this has become that like the outer dimension of your coil. Now you want some inner dimension. So what you will do is draw another cylinder. Same way. Ten is your inner teeth, and this is 0, right? With same position. Understood? So this is your inner radius of the coil, and this is the outer radius of your coil. Now just subtract it. Can you see? So now, like, sorry, you have made this structure only, but in solid form. Understood? One more advantage of this is you don't have to extend your wire, these wires that you did. So while I was telling you how to do this, you must have seen that it is somewhat difficult to do this, right? You have to be precise with the position and all of the lids, right? Position and the length of the lids. You have to be very precise with that, right? But in solid structure, like this structure, you don't have to extend any lids to give the excitation, right? So we will see how we can give the excitation. First, let's just complete our coil structure. So this is copper, right? This is your coil. Copper. Then below that, what is the material? Below the copper coil? Huh? To give a desired path to your flux lines, which material we are using below the ferrite? Sorry, below the copper coil? Which material we are using? Guys, tell me. It was ferrite, right? Am I audible? Am I audible? Am I audible?
Yes, ma'am.
Why you're taking so long to just say yes or no? Okay, fine. Is it because of weekend? So last weekend, anyways, you got free because I was not well. It's fine. Tomorrow is the last class. So just bear with me for 2 more days. Okay. So, for I told you in EV charging, below this copper coil, we place ferrite plate, right? So in this case, we will not place ferrite plate uh, like this rods, but we will place a solid ferrite place. You can place rods also. It's fine, right? I told you that it can be in any form. It can be in form of rods or it can be in form of plate also, right? So whatever is like you feel like doing, you can do it. Okay. So rods I have already told you. So now we will just okay, we will just use ferrite plate. Fine. So let's give its height as 12. Let's give it its diameter more as 2 mm, height as 2 mm, and radius more than the radius of our coil. So 40 is fine. Then height will be minus 2 mm, like below the ferrite. That's why minus 2 mm will come, like in position minus 2 mm will come. So we will, because we want to place it below the ferrite, right? Below the copper. Front view. So this is your copper plate and this one is your ferrite plate. This here and which is this. Okay. So I have copy pasted one more coil there that I just deleted. So this is your ferrite. Apply. Fine. So your coil is done, your ferrite is done. Then comes the aluminum sheet, right? So for aluminum sheet, again, just now I'm making this in the form of sheet because most commonly a sheet form of aluminum is available, right? So we are making this as sheet in sheet form, not in circular form. Okay. Size, it should be more than your ferrite. 45 is fine. 45. Minus 4. Five 20.5. Okay, I think we need more than this. 50. Uh, The size of the plate is too small. We'll just increase the size. Okay. 50 is also less. And 50 will work, I think. More than 80. Hmm. So this is your copper plate, this is your ferrite, and this is your aluminum. Can you see? So see, a ferrite is more than the dimension of your ferrite should be more than your coil, and dimension of your aluminum should be more than your ferrite. Okay. Ferrite you can make somewhat smaller also. It's too big. Fine. So we will just change this. This is copper, this is ferrite. We will just change this material to aluminum. Right? Can you see? Understood. Now this is your transmitter coil. Now uh to make your receiver coil, I told you one option is copy paste and move. The second option is duplicate. So I've already told you how to use copy paste and move options. So let's use duplicate here. Okay. Or edit, duplicate, mirror. Zero. So when you will place your tab, zero, this is also zero, and this is at some distance, example 20 mm. So it will come at above this at 20 mm. It should come, but anyways, we are parameterizing this. This length base and then all has gone up. Front view. The corner is corner. Oh, sorry. Possible. Zero, zero, air gap. Then here also zero, zero, air gap. Fine. So we have parameterized this distance so that we can see our coupling coefficient at different air gap. So from here you can change. So you might need to see the coupling coefficient when your receiver coil is just not displaced from Z direction, but from X and Y also. So in that case, here parameterize all the positions. So here now you have kept 0, 0. So you can just keep one parameter here like X distance, Y distance, something like that. I'll just show you. Instead of 0, 0, we can just change it to X distance, Y distance. You can keep any parameter for now, 0. Again, so let's see if you will change your X as 10 mm, so it will be displaced in X direction from 10 mm. That I'll show you. Top view, I'll show maybe it will be. I've changed this, right? By distance. Okay. So here, can you see it has displaced from X direction in 10 mm. Now, if you will change your Y direction, not mm, while keeping the initial position, I think I have not selected length basin on. Let's just edit it. Length base. Okay. This also edit. Keep as length base. Apply. That is that is changing. This is also changing. Excel bar 0.01. I'm keeping it as 10 mm. Why it is showing 0.01 now? Okay. X distance, Y distance, then air gap. Hmm. Mhm. Distance, Y distance, and um, so this is the way to even change your X and Y direction. But why it is not changing? I don't think. Okay, I might have done something wrong there. Let's proceed with this. But do you guys uh, understood how we can just parameterize your X and Y position also, and you can change your, you can test your coupling coefficient when your receiver coil is displaced in X and Y direction also, right? You guys understood this?
Yes, ma'am.
Yeah. Okay, so I should have just first given excitation and then would have duplicated it, but it's fine. So next step is, let's first give region. Here you can just put whatever values you want. You just have to take care that it should not touch your geometry. You don't have to worry that it should you don't have to worry about the extended leads and all, because in this case you don't have to take the extra wire to touch to the region to give excitation like in the spiral case. So here you can just give any value of region. It's just that it should be more than your geometry. Okay, your geometry should be completely enclosed in that. Air. Okay. Okay. Right now, it is done. Region. Now we will give excitation. So, do you guys remember how we have given excitation in 3D transformer case? Do you guys remember? Huh?
Yes, ma'am.
How? How? How we have given excitation in 3D transformer case? I told you for all the solid
by
windings. Hmm.
by touching the two wires uh, to region, ma'am, we can give excitation.
That was for the spiral case. I'm telling you that this will be like my 50th time that in this case, in the solid winding case, we will not touch your, we don't need to touch any wire to your region to give excitation. I'm asking you how we have given excitation in 3D transformer case. 3D transformer, where we have just taken our winding to be a block, right? A box we have considered, right?
Yes, ma'am.
So in that case, how we have given excitation? You guys forgot already. Okay, fine. We have to section this coil, right? Do you guys remember we have put one section in the winding of your 3D transformer to give the excitation? You guys remember or not? I don't think you guys remember anything, right? Okay, fine. So, to section this winding, one thing is you can directly just put rectangle here and section it. Second is select your coil, go to edit, surface, section, and section it in the YZ direction, right? So can you see now? It got section on its own, right? We now one thing is we can put your you can put a rectangle here, and second way is you can just directly section it by selecting your coil, edit, surface, and section. Okay, so your coil will get directly section. But this option will work only when your geometry is centralized. Okay. So if your geometry is not centralized, this option will not work. Understood? It
Right.
understood? So now you just want one section here. You have two, right? But can you see you cannot only select one section. You have to select both the sections. So what we need to do is what we want is we just want to delete one section. So what we will do is we will unsync this two section in short. So edit, boolean, and separate bodies. So now this will act as two separate bodies. First, it was one body, right? Now it will act as two separate bodies. So we only want one section to give excitation. So another one we will just delete. Understood? Understood?
Okay, ma'am. Okay, ma'am.
So we will do that same for your receiver side also. Edit, surface, sorry, edit surface section YZ. Okay, two section, then edit again, edit boolean, separate bodies. One we will just delete. You guys understood? So instead of sectioning it, you can put a this rectangle also here. But this is also one of the way to do it. While giving excitation to your 3D transformer, we have put a rectangle there, right? Do you guys remember? So here we have put this sheet, right? This is your 3D geometry, right? Transformer 3D geometry.
Yes, ma'am.
Yes. So we have put this section here, right? Coil terminal. This section here, right? Do you guys remember now? I told you to give excitation to any solid winding, you have to section it. You guys remember? So here we have put this section with the help of this rectangle, right? Can we use the same option here also? Hmm? Tell me now. Can we use the same option here? Yes or no? Should we try? Select your winding. Edit. Section. Surface. Will not be fine. It will X and Z, right? That is, where is surface section X and Z? Mm-hmm. We are trying multiple options, but we are not being able to do it, right? Why can anyone tell me this? Okay, sorry, X and Y, no, Y and Z. Let be your edit. Can you see? Can anyone tell me why we are not being able to use this option here? We tried all the combinations, still we were not being able to uh, get this section, right? Can anyone tell me the reason? Reason? So the reason is I told you for this section option to work, your geometry should be centralized. But here, your what is it is this geometry is centralized, but for the winding which we want to create section, it is above in Z direction, right? It is not in the center, means its center is not the center of your Ansys Cartesian system. So this option we have not used here. But if we have formed our geometry in such a way that the windings center was the center of our Ansys Cartesian system, then we would have able to use the option section here. Understood the difference? Why we are able to use this here and why we were not being able to use that there? You understood the difference? See here, this copper winding is the center of your copper coil is the center of your Ansys Cartesian system, right? That's why this section option worked here. But in the transformer case, the way we have made our geometry, the center of that uh, coil winding terminal was not the center of your Ansys Cartesian system. That's why it was not working there, but it is working here. But we can make it work there also by drawing our geometry accordingly. Understood?
Yes, ma'am.
Okay. So then assign excitation. So we will make this at first change this to solution type 2 eddy current. If you will not change this to eddy current, you cannot give excitation here. So assign excitation, then coil terminal. This coil terminal option will not come if you will not change your solution setup. I told you in some of the like solution type, different options are just exclusive for that solution type only, right? So if you will not change it, certain options you will not see. Okay? So don't get worried why it is not coming. Maybe you have not selected the correct solution type. Fine. Then number of conductors is your number of turns. So let's keep 10 here. and just see the direction. So it's it's in backward direction. So same direction following up in upward coil also, in your receiver coil also. Select the section, assign excitation, coil terminal, number of conductors 10, and okay. Fine. Understood? Now this you have to create winding. Add winding current standard because you're using number of turns, right? I told you that you can only give number of turns when you will select standard option here. You remember? I told you this, right? Number of turns you can only give when you will select standard option in your winding. Okay? 10 ampere. Okay. This is for primary. Now for secondary, I told you you can either give here 0 current, or you can give here 10 and give a phase difference of 90 degree. So it will be same. If you'll give 0 also, it will work. Or you can just give the current same as your primary winding and just give a 90-degree phase shift. You can do this in previous case also. Okay? Understood? Understood or not? I know some things are like, for now it's too difficult for you to understood, but like when you will start doing it yourself, you will start understanding some of the things. Okay? At terminals, this is done. This is also done. Then next is parameterize. Sorry, parameters. So just select it, assign matrix, winding 1 and winding 2. This is for calculating your inductance and mutual inductance, self inductance and mutual inductance. If you will not select this option, your mutual inductance will not come. Okay? Mutual and self inductance will not come. Then mesh operation. Assign mesh operation inside selection length base. You can keep default also. That I told you. This is aluminum. Okay. Then copper. Assign mesh operation inside selection length base. Copper. And then ferrite. Assign excitation. No, assign mesh operation inside selection length base. Ferrite. Okay, fine. So this is also done. Now analysis. Just frequency we will change. Rest you will keep rest if you want to keep as it is, it's fine. Let's change this. Okay. Then so optimetrics. So whatever we want to change and analyze, we will add here. So here just we can add 10 as air gap. Oh, sorry, we will add air gap as your parameter. We will start from 10, we will stop at 20 and 5. I think it's more than enough. 3, maybe 2 or 3 we will get. So it will analyze your coupling coefficient at 20, 13, 16, 19 and 20. Okay? 10, 13, 16, 19 and 20. Then let's see. Now we will just analyze this. Sorry. Capital transfer. See, it is running very fast. Can you see? Compared to your spiral winding, it is running very fast. Can you see that? It's already done. So let's analyze your coupling coefficient. Coupling coefficient we will see for winding 1 and 2, which is your Rx and Ts. So can you see your coupling coefficient is how your coupling coefficient is varying with respect to air gap? For 10, it is more because your primary and your secondary winding are close to each other, right? Right? So it is around point. How much is this point? I think 0.36. It is around 0.36, right? But as your air gap is increasing, your coupling coefficient is decreasing. That means that as the distance between your transmitter and receiver coil is increasing, less flux is getting linked to the receiver coil, because of which you are getting less coupling coefficient. You understood this? And you have seen that with solid windings, you just need like a few seconds, but with spiral winding, we needed whole day to run that, right? And it was throwing some errors also because of that extended, means you should be careful with that extended wires which is touching the region. But here you don't even need to take care of that. It's very straightforward here. Understood? Then we will see how your self inductance and mutual inductance is varying. So this is for winding 1 and 1, which is self inductance of transmitter coil. Winding 2 and 1 is your mutual inductance, right? And 2 is 2 and 2 is self inductance of your receiver coil, right? The data table is selected. We will see rectangular plot on air gap. With respect to air gap, you want to see. So see, this is your self inductance. So your self inductance does not vary much with air gap. It's not like it will not vary at all. It is varying, but it is not varying much. Okay. And this is your mutual inductance. it is varying in the same fashion as your coupling coefficient, because it is related, right? I told you this. There are more things that you can analyze. You can see here. You can see the resistance, but this value means it gives you the internal resistance of this coil, but it mostly this value does not match with your like real life coil, what your hardware coil. That's why we don't means inductance it gets matched, but resistance uh, you will find some difference in that. So mostly resistance we don't analyze. Loss you can analyze, but I think we have not selected the options, right? So for analyzing loss, you have to set, eh, for analyzing core loss, you have to set your core material. For eddy current effect, you have to select this. We have not selected it while running, so it will not show. So eddy current will come for your copper winding, right? And your aluminum plate. So that's why by default, these boxes are checked. Understood? Understood? So like more things are there that you can analyze. You can explore this on your own, but I'm just telling you the multiple options that are available. This is induced voltage if you want to see in winding 1 and 2. Okay, with respect to, we will see with respect to air gap. Theta T2. Induced voltage, flux linkage, this all you can see. If you just want to see the magnitude, you can see from, you can check the magnitude option from here. Just magnitude, then you will see. Mm, Now, can you see? You are now just seeing the magnitude here. Induced voltage in winding 2, just magnitude if you want to see, you can see here. We have not given any excitations and all here. So these are some random values that are coming. I can tell you how you can get induced voltage and power also, but uh, like I don't know whether it will become too much for you guys. Okay, fine, we will see. If we will have time, then we will do that also. Okay. Then now I want to see flux linkage. Plane, YZ, field, B, magnitude of B. So if we have kept it at 20 mm, right? By default, it is kept at 20 mm, right? And for 20 mm, your coupling coefficient is too low. It's around like 0.1 or less than that. That's why you are not seeing that Right. So that's why you are not seeing that the flux is getting linked with the receiver coil, because small amount of flux is getting linked, and that we are at 20 mm, only small amount of flux is getting linked. That's why we are not being able to see that. Maybe we can try to animate it and see. Mm, mm, mm. Setup type. Okay, so we have not saved it for every air gap, right? That's why it is just showing for this 20 air gap. For this, we have to save it at every air gap. Okay, this option. After every conversion, I think if you have selected, then you would have got it for every air gap. Oh, let's see. Understood? So understood? If you want to draw now any shape of your coil, you can draw, right? For see, the default option is available for your spiral and the rectangle coil. But if you want to draw any other shape rather than that, you can use this option. Or for drawing circular and square coil also, you can use this option, because the simulation get run very fast, and B, you will not find much difference in the values. If you will compare the spiral and this solid coil, you will get these same values, same value of coupling coefficient, mutual inductance and all. If you have same number of turns and everything, you will get same values. Understood? Understood?
Yes, ma'am.
So we are done with our solid coil also. Its analysis is also done. Um, Maybe tomorrow we will start, we will like analyze some more things here, how to make Maxwell circuit and all, because our whatever was our objective, that we have given, I've given you the list of objectives, right? So that is completed here. Okay, all our objectives have completed. So we have drawn 2D transformer, 3D transformer, then 2D inductor, then solid coil, spiral coil, and we have analyzed both, right? So our objectives are completed here. Maybe tomorrow I'll tell you some more like advanced things in Ansys. Fine. So maybe we will see tomorrow how. Okay, let me open how we can use this twin builder option. So with this coil only, in twin builder option, we will just attach the extra circuitry, the power electronics or the extra circuitry, and we will analyze with the help of this coil only. Understood? Fine. So do you guys have any doubt in how to use this option? Like how to make solid coil and how to make spiral coil? in spiral coil, you might face some difficulty with that extended leads and all, like extended wire for giving excitation. But with solid coil, you just have to section it and give the excitation. So you will not face any difficulty here. So if you will just if you will start using this option, I don't think you will ever get back to the spiral thing. Okay. I don't use spiral coils at all. I just use the solid coils only. Whatever shape I need, I can just design from this. Understood? So do you guys have any doubt? If you guys don't have any doubt, we will stop here. And tomorrow I'll tell you some advanced things in Ansys. And then we will be done with all our objectives. Actually, the objectives that I have given you, we have completed it today only. But now, because we have some extra time, I just want you to tell some advanced things in Ansys. So in tomorrow's class, we will do that. Okay? So
Okay,
tomorrow
ma'am.
we will just wind up our workshop. So whatever doubt you have, you can ask me tomorrow. So it's like a doubt session plus some more advanced things. Okay? So tomorrow you will have 2 sessions. If we need 2 sessions, I think I'll be done with only 1 session also. I'm not sure what to do. Okay, we will see. So we will just take the morning session. If we will complete our objective in the morning session only, so I'll not take the evening session. Okay?
Okay, ma'am.
Oh, fine.
Okay, ma'am.
So if you guys don't have doubt, we can just stop here and you guys can leave the meeting.
Thank you, ma'am. Thank you